back level. Cursor நடுவுல இருந்து போயிடும். Those are online. Are you able to hear me?
Yes, sir.
Rotational mechanics. And material. I thought I'll do some miscellaneous problems because I didn't help you with collisions. Last class, we didn't do problems based on collisions. So we were supposed to do on collisions, but I thought we'll do some miscellaneous problems. Or else we can start with collisions also. You remember all the formulae? Tell me if you are able to see collisions, let me know. Speed. Right. So this we saw. So we'll try out some problems based on collisions. Try this one. So I'll give you 2 minutes for all problems. You try first and then I'll help you. When is your physics exam for DAV publics? What is the date? 14th, she told exams are starting. 14th. '20. 20 or 20? 20. So you have 1 week, almost 1 week time from 14th. Was it mentioned on what they are going to ask? The derivations or problems?
Yes.
Less. Only 2% theory, 98% problems. Okay. Okay, derivations, it's fine. Derivation falls under theoretical part, okay? I didn't get you. Solids and fluids is over. How many days? 1 week. 1 week of everyday class. Is it slot period? Slot timetable. It's almost 10 hours. 1.5 hours or 1 hour? It's 10.5 hours. 5 days or 6 days? 6 days. Try this out. So what are we supposed to do in this? See, why do you want to sit and derive? We already have a ready-made expression for it. No, V1 is equal to, I told you how to remember also. M1 minus M2 divided by M1 plus M2 into U1. I told you how to remember something into U1 plus something into U2. The denominator will be M1 plus M2, M1 plus M2. Numerator alone you need to remember. Do it fast. Something into U1 plus something into U2. Check your notes. It is M1 minus M2 first. M1 minus M2 first, அதுக்கப்புறம் 2M2. Which is negative. They are approaching each other. No, if you take one velocity to be positive, other has to be negative. Minus 20 plus 20 meter per second. Okay. I'll just get my mobile. Those are online. Did you get any answer? So listen, it's very simple. The first problem says a 10 kilogram ball and a 20 kilogram ball approach each other with velocities 20 meter per second and 10 meter per second respectively. What are their velocities after collision if the collision is considered to be perfectly elastic? So we have the formula for perfectly elastic collision. What is it? V1 is equal to something into U1 plus something into U2. And what should be written in the denominator? It should be M1 plus M2. And here also you're going to have M1 plus M2. And what is going to be the numerator? M1 minus M2. And here it will be 2M2. Am I right? So since they use the word approach each other, then velocity of one should be positive and the other should be negative. Right. So this clearly indicates that M1 minus M2 is how much? So if I take this as M1 and this as M2, then this will be U1 and this will be U2. Right. So V1 will be equal to M1 minus M2 is minus 10 divided by 30 into what is the value of U1? U1 is going to be 20 plus 2 times what is the value of M2? It is 20, the whole divided by 30 into what is the value of U2? It is going to be 10. Right. So 0 and 0 are gone. Minus 20 by 3 plus. Okay, then this should be the answer. There is a mistake there. So 20 by 3 is. So we should get 20 by 3. The meaning of it is the smaller ball is still traveling in the forward direction in its respective direction with the speed of 20 by 3 meter per second. Right. Now, what about V2? So for V2, if you observe something into U1 plus something into U2, what should be written here? M1 plus M2. Here also it is going to be M1 plus M2. So here what will it be? It will be 2M1 and here it will be M2 minus M1. Am I right? So it is 2 times M1 means M1 is 10. So 10 into 2 is 20. 20 divided by 30 into what is the value of U1? Plus M2 minus M1 is how much? 20 minus 10. So it will be 10. 10 divided by 30 into what is the value of U2? But it should be minus 10. Here also that is a mistake actually. That is why it is not 20 by 3. Actually, it is wrong. I didn't check that. I told you, no, initially I told you, but I forgot to write it there. Here, did everyone do the same mistake? That is why we got the right answer. So 20 by 3 into U2 should be minus 10, no? So 1 0 is gone. So how much will it be? Minus 20 by 3 minus 40 by 3. It is minus 60 by 3, which is minus 20 meter per second. So the meaning of this is the smaller ball is rebounding. So it was traveling in the forward direction with the speed of 20 meter per second. After hitting the bigger ball, it was rebounding with exactly the same speed. That is the meaning of that minus 20 meter per second. Is the point clear? Okay. Next. So here, if you observe, here it is minus 10. Right? When it is minus 10, so 0 and 0 get cancelled. Here also 0 and 0 are gone. How much will it be? It will be minus 4 by 3 plus 10 by 3. How much will it be? 6 by 3, which is going to be 2 meter per second. It will be 2 meter per second. I think, let me check. It is 40 by 3. Minus 40 by 3 minus 10 by 3. It is minus 30 divided by 3. It should be. Is it coming as minus? No, no. This will be 40. This will be minus. So plus 30. It should be 10 meter per second. Both cannot come out in minus because they have to travel in opposite direction. They will rebound. Okay, that's what is supposed to happen. Am I clear with this? Okay. Can you do the next one? Make it fast. So when they say predict the outcome of the collision, they are asking what is the speed with which they are going to move after the collision. Okay, that is the meaning. So assuming it to be perfectly elastic. So when they say it is perfectly elastic, right, you can take V1 and V2 with the same formula. Hmm. Those who are online, are you able to hear me? Are you able to do this problem?
Yes.
Okay, try it out. Tell me what is the answer for this. Yes. You find something interesting. See what you have. Check out, no? That's right. So what is the answer? You can try this one. See, that is not 7, that is a question mark. What is their common speed after collision is a question mark. And what type of collision is this? So you know the answer. No, others you concentrate on the second problem. The second problem, what did they say? Both the objects are traveling towards each. What is M? Got the answer as M. V1 is equal to M is what you got. How can velocity and mass be dimensionally same? So made some mistakes. Actually, so 2m divided by 2m into u2 is what you're going to get. Okay, let it be. I'll finish this one. So listen. See, listen. In this problem, there are two ball bearings of mass m, each moving in opposite directions with equal speeds v. Okay. And they collide head on with each other. Predict the outcome of the collision, assuming it to be perfectly elastic. So what is the relation? V1 is equal to, we have this formula m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2, which implies v1 is equal to, since m1 and m2 are same, this parameter gets cancelled. So it is going to be 0 into u1 plus, in the place of m2, if you substitute m, you will have 2m divided by 2m into, what is going to be the value of u2? It is minus u. Meaning, if you take the object of mass m1 to move in this direction with speed v, and an object of mass m2 to move in this direction with speed v, then here you will have minus, it is not u, rather it is going to be minus v, because that is the speed they have given. So 2m and 2m will get cancelled. What is the answer you are going to get? V1 will be equal to minus v. It is minus v. Okay. So what is V2? V2 is equal to 2m2 divided by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. So again, this is going to be 0. Right, this is going to be 0. So if you substitute m here, 2m divided by 2m into v. So it will be 2m divided by 2m into v. This will get cancelled and give you 1. This is equal to v. Meaning, the first object will rebound with the speed of v, and the second object will also rebound with the speed of v. Meaning, if there are two objects of same mass traveling with same velocity, they collide head on, and if it is a perfectly elastic collision, they will exactly rebound in the backward direction with the same velocity. That is an important observation that you need to do. Okay, next time onwards, if you see the objects to be of equal mass and they are moving with common velocity in the opposite direction, right, then what is going to happen? They will rebound. It is because of this formula. You're able to understand? Yeah. So next is problem number 3. So there is a railway carriage of mass 9,000 kilogram moving with a speed of 36 kilometer per hour, collides with a stationary carriage of the same mass. So there are two carriages, right? One is moving with a speed of 36 kilometer per hour, which is going to be 10 meter per second. 36 kilometer per hour is going to be 10 meter per second, and the second object is at rest. U2 is 0. After collision, the carriages get coupled. So they both are going to become a single compartment. In the sense, here you have 9,000 kilograms and here you have 9,000 kilograms. So after collision, what is happening to the system? It will be 9,000 plus 9,000. And this system starts moving together with a common velocity. Now the question is, what is the common speed after collision? So what is the common speed of the system after collision? So how to solve this? Since it's a perfectly inelastic collision, it is only the linear momentum that is conserved. So when I talk about linear momentum, initial momentum of the system is going to be 9,000 into 10 plus the initial momentum of the second object is 9,000 into 0 is equal to 18,000 into common velocity v. So this is going to be 0. So 9,000 into 10 is going to be 90,000 is equal to 18,000 into v. Cancel this and this. It's going to get 5 times. Right. So v will be equal to 5 meter per second. Right. So it is going to be 5 meter per second. And what type of a collision is this? It is a perfectly inelastic collision. So it's a perfectly inelastic collision. Right. So those who are online are able to understand?
Yes, sir.
Okay. Shall I proceed? Copy. So I'll do 2 more problems based on this, then we'll go to the miscellaneous. Okay. Shall I proceed? So the next question is, what percentage of kinetic energy of moving particle is transferred to a stationary particle when moving particle strikes with a stationary particle of mass 9 times in mass, second equal in mass, and third 1/19th of its mass? So there is an object of mass m which is moving, and it is colliding with a stationary particle whose first case, the stationary particle's mass is how much? 9m. In the second case, stationary particle's mass is m. In the third case, it is m by 19. So in all these three cases, you have to find out what is going to be the percentage of kinetic energy of the moving particle. That is when, how much is it getting transferred to the system? Calculate. Okay. So if nothing is given here, right, you can assume it to be perfectly elastic position. Yeah, kinetic energy is conserved, but it is the kinetic energy of the system. It is not the kinetic energy of individual particles. All right. You will write it, but you don't know how much is the value of Ka after, no? Again, you have to apply that big formula, V1 is equal to. Then you will find the value of V1 and V2. Then you will be able to write what is the value of the kinetic energy of each particle before and after collision. It's fine. That is why the question is very clear. They didn't ask you what is the velocity. They asked what is the percentage of energy transfer. When you derive it as expression, you will only get a number. That is why you see mass is also not given in the problem because mv square will get cancelled. What is percentage change? Final minus initial by initial. Everywhere you will have mv square. Cancel it. So calculate the value of V1 and V2 and tell me the first case. You know the formula, just substitute. What is the value of V1 and V2? Sorry? V1 is minus in the first case. Is that what everyone is getting? V1 is equal to minus 4 by 3 V U1. Okay. Plus 4 by 5 minus 4 by 5. So you're getting 16 by 10 actually. 16 and 8 by 10. Okay. So for V2, how much is V2? When you're dealing with those fractions, you have to do them faster. That is the only challenge. So V2 is 1 by 5. They are not given here. So they have calculated it as per the formula. But I'll tell you. So you have calculated this no. So V1 is equal to this value and V2 is equal to 1 by 5 times U1. So what are they asking? Listen to this carefully. What percentage of the kinetic energy of the moving particle is transferred to the stationary particle? So the percentage transfer, right? So what is the percentage change formula? Is equal to K final minus K initial divided by K initial into 100. So you remember in units and measurements, there is something called as fractional error. In the fractional error, this is what you do. Final minus initial divided by initial. That is fractional part. Into 100 will give you the percentage. Okay. Calculator. So what is the initial kinetic energy of the system, of the particle? Half m u1 square. Half m u1 square. What is the final kinetic energy of the particle? It is going to be half m v1 square. So how much is that going to be? So half into m into v1 square is 16 by 25. Right, 16 by 25 into u1 square. So how much will this be? It will be 16 by 25 into half minus, sorry, into half m u1 square. So K final minus K initial means it should be 16 by 25 minus K initial is how much? 1, the whole divided by 16 by 25. Did you understand what I did? It's not 16 by 25, sorry, 1 by 25. Right. Did you understand what I did? K final is 16 by 25 times half mu1 square. You want me to write it in detail? Got it or not? Your faces are blank. Got it? See, okay, I'll write it for others' sake. 16 by 25 into half m u1 square minus, what is K initial? Half m u1 square. What is the K initial again? Half m u1 square. What gets cancelled? Half u1 m u1 square gets cancelled. So you're left out with 1 here and 1 here. You're able to understand? So 16 by 25 minus 1. So 9 by 25, right? It is 9 by 25 with a minus sign into 100. So minus 30, minus indicates that 36% of its energy is lost. Okay, that's what this is. So what they have done is they have taken a generic value and then solved it. If you solve it like that, it will become complicated. Don't go like that. So what is the procedure we followed here? What is that we followed? We need to calculate what is the initial, what is the final velocity of the first particle, what is the final velocity of the second particle. Apply this formula of K final minus K initial divided by K initial into 100. Okay. So in this case, when it is of equal mass, right, it is actually simpler. If there is an object of mass m, which is moving with the speed u1, and it is colliding with another object of mass m, which is at rest, okay, which is at rest, then what will happen is, this will transfer all its velocity to this. So the first particle will come to rest, second particle will start moving. So how much is the energy that is going to get lost? It will be half m u square, sorry, 0 final, since this is going to come to rest, what is the final kinetic energy of it? 0 minus half mu square is the initial kinetic energy divided by the same half mu square is the initial kinetic energy into 100. 100%. There is a 100% transfer. Because see, this is coming to rest, the other object starts moving, no? Why I told that is, did you understand how I was able to tell you I'm using the same formula only? So remember, when one object is moving with a speed u and the other object exactly of the same mass is at rest, then what will happen? The first object will come to rest and the second object will start moving with the initial velocity of the first object. So that's what happens here. Did you understand or not? So 100% transfer is going to be there. In this case, what is going to happen? Same thing. I am assuming that you people can try it. Okay. You understood the concept, no? I don't want to waste time on calculations. Clear? I'll proceed to the next one. You want to make a note? Make a note of this point alone. This will be asked many times. What is the percentage loss? Percentage change? So remember, if they ask only fractional change, write it as K final minus K initial by K initial. That is fractional. Into 100 will give you percentage. Clear? Did you all finish copy? Okay, there's too much. Okay, maybe one last problem that you can try. Try it. So I'll give you the hint. So the question says, a ball is dropped to the ground from a height of 2 meters. Right, let's try to describe the scenario with a diagram. So there is ground, there is an object whose initial velocity is 0, and the ground is at a distance of 2 meters below it. So after it hits the ground, what is going to happen? Had the coefficient of restitution been 1, listen to this. So it would have come back to the same height. But the coefficient of restitution is not 1, it is 0.6. Right, it is 0.6 means it does not come back to the same height, rather it will come down, come to a lesser height than 2 meters. Right. Now they're asking to what height will the ball rebound? So if the coefficient of restitution had been 1 in this scenario, you could have directly written it as 2 meters. But in this case, what is happening? It is 0.6. So what is the formula for coefficient of restitution? E is equal to U1 minus U2 divided by V2 minus V1. If you observe, this is the first object in the system, this is the second object in the system. So the second object is always at rest. Right. So when I ask you what is the value of U1, what are you going to say? U1 is not 0. U1 is the velocity attained by the particle just before collision. So U1 means you should not take this scenario. U1 is the velocity attained by the particle before collision, before the ball came in contact with the ground. So if you observe, it would have been root of 2gh, where h is going to be 2 meters. Why did I write that? You know why I wrote that? Because I use v square minus u square is equal to 2as. So during the journey of the ball from the top to the ground, whatever velocity is attained by the particle just before collision will act as the initial velocity in this case. Okay. So v square, for v I will write it as u1 square minus what is the value of u? During the journey, initial velocity is 0 is equal to 2 into what is the acceleration due to gravity? If I take it as minus g, and the displacement is also going to be minus 2. Yeah, h. It is minus 2. So which is going to be 4 times g or 40. I'll take it as 10 for instance. So it is going to be 40. Right. So 40 meters square per second square is going to be the value of u1 square. So u1 will be equal to root 40 meter per second or 2 root 10. It will be 2 root 10. Minus what is the value of u2 divided by what is the value of v2? 0. What is the value of v1? That's what we need to find. So minus v1, this is equal to 0.6. Make sense? Okay. So you have one unknown and one equation. One unknown and one equation. You can find the value of v1. So that v1 will be the velocity of the particle after collision. So this v1 is the one which is going to, v1 is the velocity which will help the particle to raise to a certain height. Right. So after you calculate the value of v1, what you need to apply is, you need to apply v square minus u square is equal to 2as. So this v will be equal to 0 for the upward journey. So 0 minus what is u square? I told you the velocity attained by the particle after collision will start acting as the initial velocity for the upward journey. So in the place of u, I should substitute V1 is equal to 2 into what is the acceleration due to gravity? It is minus g, and the displacement is what you need to find, which is going to be h, right? So from here you will get V1 square is equal to 2gh, right? So this clearly tells you for you to find the value of h, right? H. You need not calculate V1, rather calculate V1 square itself. Okay. So from here, if you observe, right? From here, if you observe, what will be the value of V1? So V1 will be, or V1 square will be equal to 2gh divided by 0.6. But 2gh, we already know it is 40. So 40 divided by 0.6 means you can write it as 6 by 10. It will be 400 divided by 6. So V1 square is 400 divided by 6. Take and put it here. So it will be 400 divided by 6 divided by 2 into 10. This and this will get cancelled. We cancel this 20. So answer will be 10 by 3. Or 0.6 square. No, then it will be 36 by 100. So it will be 36. So when it is 36, it is going to be 10 divided by 18, or it is going to be 5 by 9. Actually, it should be less than 2. It will be 5 by 9 meter. Did you understand? So it will be 5 by 9 meter. I don't know how they did it, but did you understand the logic that I gave? Is that clear? So there are 2 points to be noted. What will be the value of V1 here? Sorry, what will be the value of U1 in the case of coefficient of restitution? U1 will be the velocity attained by the ball just before collision. So what will be the value of V1? V1 is the velocity attained by the ball just after collision. So U1 will act as what? U1 will act as the, when you write the equations of motion, U1 will act as the final velocity of the downward journey, right? And when you write the equations of motion, V1 will act as the initial velocity of the upward journey. These 2 points are to be in your mind, or else you cannot solve it like this. Are you all clear? Right? So this is how you solve a problem where coefficient of restitution is involved. So make a note of it. If there is any question, please ask. What is the doubt now? I wrote it in complete reverse. Sir. I wrote it in complete reverse. I explained under gap, I concentrate. Can you do it in the reverse and tell me? Can you try it out? V2 minus. It is a ratio of the relative velocity of separation to the relative velocity of approach. I explained when I wrote it in the reverse. இது இப்பதான் பாத்தியா இல்ல ஃபர்ஸ்டே பாத்தியா? அப்படியே சொல்ல வேண்டியது. சொல்ல வேண்டியது. Because I was trying to explain this, எப்படி யோசிக்கணும்னு சொல்றத தப்பா எழுதிட்டேன். It is a relative ratio of relative velocity of separation to the relative velocity of approach. So you just need to do it in the reverse. Five by 9 is how much? See, don't only thing that will change is, see, listen, this whole thing is not wrong. The whole thing is not wrong. The only thing that will change is V1 will go to numerator, root 2GH will come to the denominator. That's it. Only V1 square alone change it, substitute it there. You will get the answer. You strike V1 will go to numerator and V2 root 2GH will come to the denominator. So it should be 36 divided by 400. See. So don't erase everything. So V2 minus V1 divided by U1 minus U2. So V2 is 0 minus V1 is how much? That's what we need to calculate. The whole divided by U1 is root 2 GH. This will be equal to 0.6. Am I right? So V1 will be equal to 0.6 into root 2 GH. So 0.6 can be written as 6 by 10 into, this is going to be 2 GH. So when you write V1 square, it will be 6 by 10 the whole square into 2 GH. It will be 36 by 100 into 2 GH. 2 will cancel this 50 times. So 36 means it will go 18 and this will be 25. So 18 into 10 into 2, the whole divided by 25. This will go 2 times, this will go 5 times. So 4 into, this is 72, 72 divided by 5. That's what you need to substitute it. So 72 by 5. So here what will happen is it should be, but are you all convinced with the logic? So 72 by 5 divided by 20. So it is going to be 36 divided by 10. So it is 36 divided by 50 or 3.6 divided by 5. How much will this be? 0.7 something should come. There is no other mistake, no? So I'm not concerned about calculation. Calculation part, I'm leaving it to you. My brain is only working on explaining the concept. Is there any mistake? Numbers part, you take care. Okay. So 6 by 10 the whole square. Yeah. Again, you have to write everything. Okay. So can we end collisions with this? Right. So try this. So each problem, let's have 3 minutes maximum as timer. Concentrate and do it. A 6 kilogram block initially at rest is pulled to the right along the horizontal. Surface having a coefficient of kinetic friction 0.15 by constant horizontal force of 12 Newton. Find the speed of the block after it has moved 3 meters. So tell me one thing. By looking at this problem, right? What is the idea you people are getting? What equation do you think you are going to apply? See, I told you there is an importance of one theorem which can be used anywhere in physics, in most of the cases. It's not energy conservation. Can you use energy conservation in this case? Can you use energy conservation in this problem? Why? When can you use energy conservation? When the forces are Conservative. So here is all the forces conservative in nature? What is the non-conservative force here? Yeah, friction. But I told you there is another theorem which can be used anywhere. Work energy theorem. So work energy theorem speaks about the relation between work done by all the forces and the what is the equation? Work done is equal to change in kinetic energy. Correct? So work done is equal to change in kinetic energy. What are they asking in this problem? Find the so when you need speed, can you think of work energy theorem and then apply it so that you will get the value of speed? Did you understand? So the best way is, first of all, don't look at any of the formulae from the back. Draw a diagram and then do it. Only then you will understand which force is acting in which direction. So there is a 6 kilogram block initially at rest. Draw a floor and a block which is initially at rest. Right? So put 6 inside that block. So it means that the mass. It is initially at rest, put U is equal to 0 on top of it. So the surface having a coefficient of friction of 0.15 and this block is pulled by a constant force of 12 Newton. When it's pulled, the force is going to be away from the block. Pulled means the force is away from you will understand. Find the speed of the block after it has moved a distance of 3 meters. So now what you do is draw the new position of the block, draw the same block again, taking an approximate distance of 3 meters and try to analyze the situation. So when you write the distance is right, distance should be written from the center to the center. Distance is not written from the end to end. Distance of a solid is written from center to center. Why center to center? You'll understand in next chapter. Are you all clear with the diagram? Got some perspective? Okay. So those are online. I'm sorry, guys. Well, I think there was network issue. Till where could you hear? Those are online. Till where could you hear? Am I audible? To those who are online, am I audible? What is the answer? See, I already told you how to apply the formula for work done for a constant force. What is the formula for work done by a constant force? There is only one formula. Very first formula we saw in the beginning. Force into displacement. அவ்வளவுதானே சொன்னேன். It's force into that is more important. Because here there are two forces which are responsible for the motion. One is the horizontal pulling force and the other is the frictional force. So if you forget cos theta, you will get both of them to be plus. Actual problem ஒரே step தான். You will get the answer in one step. I'm trying to teach you the logic. Are you able to understand? Did you all draw the diagram? Can you all show it to me? Can I have a look at it? Distances are calculated from center to center, not edge to edge. Okay. But next time correct it. Okay. Those are online. Am I audible?
Yes,
Listen.
sir, you're audible.
Listen. So the question is, So question is, a 6 kilogram block initially at rest. So there is a horizontal surface. There is a 6 kilogram block which is initially at rest. It's being pulled by a force of 12 Newton, right? And it has moved through a distance of how much? So it has moved through a distance of 3 meter. And there is a coefficient of friction of how much value? 0.15 that is acting. It is a coefficient of the kinetic friction. 0.15, right? Okay. So find the speed of the block after it has moved a distance of 3 meter. So listen. So there are 4 forces acting on the system: pulling force, frictional force, normal, and weight. Right. If you observe, normal and weight are perpendicular to the displacement. So they don't done by all forces is equal to change in kinetic energy. So what are all the forces that are causing the displacement? So 12 is causing a displacement of 3 meter. What is the angle between them? 12 Newton and 3 meter. They both are in the same direction. So cos of 0 degrees plus what is the frictional force that is acting? Mu mg into cos. Mu mg is the force into displacement is 3 cos 180. Right. This should be equal to the change in kinetic energy. It is half mv square minus initial kinetic energy is 0. One step, you will get the answer. So all that you need to do is multiply. So 12 into 3 is 36. So you will have a minus here. So cos 0 is 1, cos 180 is minus, so minus. 6 into 10 is going to be 60. 60 into 0.15 is going to be 9. Right. So 9 into 3 is 27. So 36 minus 27 is equal to half. What is the mass? It is 6 into v square. So 2 and this will get cancelled thrice. So 36 minus 27 is 9. So 9 is equal to 3v square. So which implies v is equal to square root of 3. So v is equal to square root of 3, which will be 1.8 meter per second. So this should be the answer. Is that what you got? Hmm? Clear? Shall I proceed? See, remember, this one equation can help you to solve most of the problems in physics. So I'll just tell to people who have learned mechanical properties of fluids, you would have learned something called as Bernoulli's theorem. So this is the logic. Work done by all the forces is going to cause change in kinetic energy. You can use that for the derivation process. Okay. It's a similar problem, but with a different object. So in the previous case, it was friction. Now it is a frictionless surface, but it is a frictionless surface, but there is a spring. But still, you can use work energy theory. Hold on. நான் போட்டிருக்க work energy theory தான். That's an important derivation. A 6 kilogram box runs into a light. So when they say light, what is the meaning of it? They kept a laser light. Meaning? So here it is massless. Okay, light spring of force, because all the springs and the strings that we are dealing in physics, by default, even if they didn't give you light, you should understand that it is massless. That's another thing you need to have it in mind, because you don't have problems on how to deal with mass. Okay. So frictionless surface runs into a light spring of force constant 75 Newton per centimeter. This is where you need to be careful. Use the work energy theorem to find the maximum compression of the spring. Had they not given it also, okay, you can use work energy theorem. So that's always a safe bet. Okay. But in this problem, my question is, am I allowed to apply energy conservation? There is no friction, but there is spring force. No, is spring force conservative or non-conservative? It's conservative. So all the forces in the system are conservative. So you can apply that also. So what I would suggest is, don't look at this like a problem to solve and find the answer. Try to understand the concept, apply and solve using work energy theorem and energy conservation theorem. Check if both are giving you the same answer. If not, the theorems are wrong. We'll try and see. As I told you, draw the diagram, you'll understand. Half of the problem is solved there itself. So when you apply the work energy theorem here, tell me what are all the works that are being done? Who are all doing the work? Is there any force that they have given? It's only the spring force. So what is the work done by the spring force? What is the formula for work done by the spring force? We discussed in the previous class. Last Thursday we discussed. Thursday we discussed about potential energy of a spring, and Friday we discussed collisions. Check. Minus half kxm square. So should you use a minus or not? Should you use a minus or not? So listen. There is no minus. Work energy theorem is the minus one. Because work is of three types. What are the three types? It can be positive, negative, or zero. But energy is always positive. So when you apply energy conservation theorem, never apply the minus sign. Never apply sign convention at all. Whereas when you are applying work energy theorem, for work, you need to be perfect with your sign convention. If not, the answers will not come. I'll show you why, what will happen. See, if you don't apply it, see what would have happened. Work done by all forces is equal to change in kinetic energy. So what is happening? There is a block which is already having a velocity associated with it, which is 3 meters per second. So there is a spring which is there, which has a spring constant of 75 Newton per centimeter, which is going to be 10 power minus 2 meter. It is 7,500 Newton per meter. Clear? So when this spring, when this block goes and encounters the spring, what is going to happen? With whatever velocity the block has, it will try to compress the spring, but it cannot do it beyond a certain point. When all the windings have come very close to each other, it cannot compress. So what should happen to the spring? What should happen to the block also? The block will come to rest during the instant the spring has taken up the maximum compression. Is that not the logic? So work done by all the forces is equal to change in kinetic energy. Work is being done by which force? It is the who's actually stopping this block. Who is stopping this block? It is the spring force. So work done by the spring force is minus half k xm square is equal to, when I say change in kinetic energy, change is always final minus initial. So final kinetic energy is 0 minus initial kinetic energy is half into m into u square. Now listen to this carefully. If I write this as half into, what is the value of k? 7,500 into, we need to find the maximum compression. That's xm. So xm square is equal to minus half into, what is the value of m? 6 into u square, that is 9. So half and half are gone. This will get cancelled 2500 times with 3, and this will get cancelled 2 times. Again, this will cancel 1250 times. So xm square is equal to 9 divided by 25. This there will be a minus sign. Means, had I missed this minus sign, this is the mathematical expression you will get, which is wrong. That is why when you're applying the, see in this step, I deliberately left it. I didn't put the minus sign here. So you need to put the minus sign here so that this minus and minus get cancelled so that it will be plus. 1250. Okay. So xm is going to be equal to square root of 9 is 3. What is the square root of 1250? So what is the square root of 1250? Sorry, is it 20? It's not 25. How much will it come out as? So how much will it be? Can I take it as 36? But the answer should match. Everything is in terms of 0.5. So once let me check, there could have, is it Newton per centimeter or Newton per, okay, I don't have a solution here. So it is 3 divided by square root of 1250, because see, every answer is in terms of 0.5, right? Suppose had it been only 75 Newton per meter, right? What would have been the answer? 3 by something, that should be lesser than 1 also. So I think it is 75. There could have been a printing mistake also. 75 Newton per meter. See, suppose take it as Newton per meter. Tell me what will the answer be? Then also it is less than 1. Then also it is less than 1. But none of the answers are matching, no? Okay. Let's assume that xm is equal to square root of 9 divided by 1250 itself. Let's not disturb this. Okay, but what did I tell you? We need to get the same answer if you're going to use the energy conservation theorem also. So when you apply the energy conservation theorem, what does it state? The initial energy, the total initial energy should be equal to the total final energy. So what is the initial energy of the system? Understand how to apply it. Here, when I say system, are you all with me? So this is alternate method. I hope this you understood. I'm not concerned about the answer. Logic is clear, right? Listen. See, the alternate thing is, if I apply energy conservation theorem, I need to take the total system into consideration. Here, what is the total system? It is the block plus the spring. So what is the energy the block is possessing in the initial case? It is a kinetic energy. Plus, what is the energy possessed by the spring? Nothing. Because it is in its relaxed state. This should be equal to, what is the final energy of the system? Finally, the block is coming to rest. Plus, what is the energy possessed by the spring? Half k xm square. So did you understand? Here I didn't apply the minus sign. Because when I deal the half k xm square as energy, I'll put a plus sign. Whereas if I deal it as the work done, I'll put a minus. So this is where you need to have clarity. Sorry? Either 3 by 36. Oh, it is centimeter, like the meter level. Correct. Yeah. So how much are we getting? Maybe that's the answer. I'll check and tell you, but that's not the problem. But did you understand the concept? Solomon. I changed it there. That is why I got 7,500. 100 கிடையாது. 1 centimeter is 10 power minus 2 meter. So 10 power minus 2 will go to the numerator, no? It is not 75 by 100. You wrote that as 100. 75 by 100. Because 1 centimeter is not 100 meter. 1 centimeter. That's not how it goes. Even if you get 8.5, right? That 8.5 that you got will be in meter. It is not centimeter. Look at the answer. It is in terms of centimeter. Got it? Yeah. So I did the conversion here itself. If you observe 75 divided by 10 power minus 2, that went up. So it became 7,500. Okay. But is the concept clear? So you now tell me, when are you supposed to apply the minus sign? When you're dealing with a particular quantity as work done. Because work can be negative, positive, or zero. Whereas when you're dealing it as an energy, you should always be positive because energy cannot be negative. Okay. So, but if you see, both are giving you the same mathematical equation. Now, this is very simple. The third case, the change in kinetic energy of a particle is equal to the work done on it by some force. It's the work done by all the forces. So when I say all the forces, it can either be conservative or non-conservative. So work done on it by the aerodynamic force, no. Loss in ambient kinetic, and ambient in the sense the surrounding kinetic energy, no. When an object moves with a constant speed along a circle, so there is an object that is moving with a constant speed along a circle. So the speed of the particle is always taken tangential to the surface, right? So what can you conclude? No force acts on it. It is wrong. What is the force that is going to act on it? There will always be one force. There will always be a centripetal force acting on it. So when they say an object is moving at a constant speed, this is also called as uniform circular motion. So that force is going to be mv square divided by r. No acceleration is produced in it. No centripetal acceleration is there. No work is done on it. I don't know. Its velocity remains constant, obviously. Its velocity is going to remain constant. But what about no work is done on it? Actually, in this case, actually the velocity remains constant is also wrong. Direction is changing. Because when you talk about velocity, there's a speed with the direction. Speed is constant, but its direction is changing. There is a change in velocity taking place. That is, so work done on it is zero, but I need to give a justification for it because the force acting on the particle is acting towards the center. So force and this velocity is going to be the displacement's direction also. So what is work done? Force F vector dot S vector. If force and displacement are perpendicular to each other, work done on the system is zero. So that is the reason why no work is said to be done on a particle which is rotating with a constant speed. That's a very, very important point. About this, you will learn next year in one of the concepts called magnetic fields. There will be a particle rotating in, will be a charged particle. Here there is a particle of mass. So there are often, there are some questions asked. What is the work done on that charged particle? Answer is zero, same logic. Can you tell me what is the logic? Force, which force? Centripetal force and the displacement are always perpendicular to each other. So work done by a perpendicular force is always zero. Clear? So that's the answer. Okay, this point you can just make a note of. Whenever there is a particle rotating with a constant speed, in which motion? In what kind of a path? Whenever a particle is rotating with a constant speed in a circular path, work done on the particle is zero. Work done on the particle is zero. I hope it is clear. So did you all reason also? What is the reason for it? Because the force, which force are we talking about? Centripetal force. Because the force and displacement are always perpendicular to each other. Clear? In which case is the work done zero? Force and displacement are perpendicular to each other. First answer. Force and displacement are in same direction. No. Force and displacement at angle 45. No. Angle 75. This is a simple question. A boy pulls a 5 kilogram block along a 20-meter long horizontal surface at a constant velocity by applying a horizontal force F. If the coefficient of kinetic friction is 0.2, how much work does the boy do on the block? And the acceleration due to gravity can be taken as 10 meter per second square. So it's a simple question actually. There is a boy pulling 5 kilogram block, right? There is a 5 kilogram block. He's pulling with a constant force F, right? And this being pulled for a distance of 20-meter long by applying a constant velocity. Sorry. It is pulled with a constant velocity by applying a horizontal force. If the coefficient of kinetic friction is 0.2, so there is a frictional force acting in this direction, right? Question is, how much work does the boy do on the block? There is a slight tricky part here. It's very simple. Listen to it. There is one important point we need to focus on. We should ask a question. See, whenever there is a force acting on an object, the object is supposed to accelerate. But here, what is happening? The object is moving with constant velocity. How is it possible? But still, they are saying, what is the work done by the boy? And none of the answers is zero. So, what is happening here is, listen to this carefully. They have clearly mentioned he is applying a horizontal force of F, right? What should be the magnitude of that force for the system to have a constant velocity? This force should exactly be equal to the frictional force. You can ask me, how is the system moving? It can move, and this is said to be a condition of equilibrium, where there are forces acting on the system, but the system is still having zero acceleration. So whenever there is a condition where a system has zero acceleration, you call it as equilibrium. So equilibrium is again classified into two types. One is called as static equilibrium, and the second is called as dynamic equilibrium. This is an example of dynamic equilibrium. So static equilibrium means a book lying on a table. It's a static equilibrium because weight and normal force are balancing each other and the object does not have velocity itself. But if there is an object which has velocity but zero acceleration, you call that situation to be dynamic equilibrium. So this is an example of dynamic equilibrium, and that is the reason why they didn't give you the value of capital F, because they're expecting you to know that the value of capital F is exactly equal to the frictional force. So what is going to be the frictional force? So F is equal to mu mg. Mu is how much? 0.2 into mass is 5 into 10, which is going to be 15 to 2, 1. So the frictional force is 1 Newton. 10 Newton, sorry. Frictional force is 10 Newton. Right, yeah, 1 into 10. Yeah, frictional force is 10 Newton. So work done is equal to how much? They're asking work done by the boy. So boy is applying how much force? He is applying 10 Newton in the direction of displacement. That is why the answer is positive, not negative. You're able to understand. So work done by the boy is equal to force into displacement into cos of 0 degree. Answer will be 200 joule. This is the answer. You understood? So the tricky part here is understanding what the constant velocity means. Okay. So make a note of it. All are almost similar kind of problems. I thought I'll do, but yeah. So on Saturday, did you all get the message about Saturday? So there is a test from 5 to 6:30 and you have Newton's laws of motion, the complete chapter. Okay. So I'll give it for 40 marks, 1.5 hours. You maintain the time properly and do it sincerely, practice and come. Are there any topics in that which are troubling you? Newton's laws of motion. So I'll just tell you one more thing. I didn't start with the new chapter today because I completed this, but I didn't do problems on this. Okay. In a similar way, for Saturday's test, I'd like to help you with the problems from Newton's laws of motion. Okay. But I would like to tell you, I have some workshop tomorrow from 10 to 7. I'm not available. So I have to put another teacher. Unlike last time, don't keep him clueless. Okay, I've already informed. I'll give him the worksheet. I'll give him this kind of a sheet and ask him to solve problems, make use of it. But the sheet is going to be from Newton's laws of motion. Is that clear? At least 10 to 15 problems, he can solve it. So tomorrow's class will be from 4:45 to 6 p.m., but it will be online because I'm not there. Am I clear? So, but on Saturday, you have to come here and write it. Maintain proper timing. Be here by 5 and finish it by 6:30. Don't extend and write it. Plan your time. Am I clear with that? Okay. So secondly was I wanted to say something. Yeah. For this thing, right? The mechanical properties of solids and fluids. I will not be able to teach it. But there are few recordings that I've already done. Okay, I've already prepared some slides. The next 3 days I'm occupied, I'll be honest. Monday also I'm a little occupied. So maybe from Tuesday, I will record and give you the important derivations from those 2 chapters. I'll put it on YouTube itself. You can watch it. Okay, Bernoulli's theorem and equations of motion, Venturi meter, I've already derived. It's there on YouTube, but I think I did it 1 year back. The video clarity is not that great. I'll do it again and give it to you because the diagram is not clear. I'll again do it and give it to you. Make use of it. So if you can give me the priority list of topics that you didn't understand, I'll first work on that so that we can save time of yours. Okay. So you give me the list of topics, right? From both the chapters. I don't think mechanical properties of solids is that tough. You can handle it, right? Only thing is the stress strain curve is what you need to know. And you need to understand how the work done is going to get stored in some form of energy. So you'll have half into stress into strain or a formula. That is the thing. So mostly that chapter is only used for understanding the elastic properties of material. But fluids, I understand, is genuinely tough. I'll not say tough, it is very big chapter. Too many formulae, static, dynamic, therapy, viscosity, and you will have something called as capillary action. Is it taught? Capillarity, everything is taught? Okay. Surface tension, everything is there. No, okay. I understand. So you can tell me the list, you can give me the list of topics. Okay, which you want me to give it in. Let's break it as 2 phases. First phase, I'll give you the concepts that you asked me. Second phase, I'll work on the topics which are pending and give it to you. Okay. Will that help? Okay. So that chapter can go off like that. There is anything also you can let me know. So what you can do is, you can just take 5 to 10 minutes of time. You all have your school notes. All have your school notes. Just go through the concepts. Okay, whichever topic you feel you want another whatever you say, brush up from my side. You can just write down. There is a suggestion box kept there. Just write down the topics and put it. I'll take care of it. But I can give it to you only on next Wednesday or Thursday, because for me to record, it will take some time and editing will take some time. Okay. Is the point clear? So Adukula, you give me whichever is possible from my side, I'll do it. Sharia, any questions? All clear? Right. So just take 5 minutes time. You can sit there. You want to discuss, you can discuss. There is a box kept outside. I think you would have seen it. There is a green color sticky notes. Write down the topics, put it in that. I'll just do it and give. Okay. See, those are online. Is everything clear?
Yes, sir.
So you also have any topics that you want me to help with? Okay, you let me know. I'll work on that and give it to you guys. Let's say you have some school exam where I have not covered certain topics, right? I'm going in the order of NCERT, right? If you have any chapter that is not covered by me, you can let me know the topics. Ananya, Shweta, Ritika, and Meghna. I hope I'm clear.
Yes, sir.
Can you guys respond, please?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Yes, good. Okay. So as I told you, tomorrow there will be a session based on Newton's laws of motion, and you can get your doubts cleared from the other faculty who's going to handle it. Okay. So if there are no questions, we can wind up this session.